Okay, hello. Okay, today we shall be developing Granger Causality test, and we have three variables such as export, import, and money supply, right? We have these three variables: export, import, and money supply, and we assume that our three variables are stationary, right? That we assume without testing, right? That means we assume that our three variables are stationary because we need stationary data to run Granger causality test. Okay, the variables are here. So the variables are here. You can see observation from 1960 until 1990, and the first variable is export, the second one is import, and third variable is money supply. So we have all these three variables so far, right? And now we shall estimate the model, the Granger causality test. So first we go to statistics, then we go to multivariate time series, then you choose vector auto regression model, right? Okay, then we take our all variables, export, import, and money supply. So these are our three variables. Okay, so first time we take lag 2. You can see here, right? Here, first time we take lag 2. And then, okay, first time we take lag 2, and then we take lag 4, then we take lag 6. And when when the number of lags will change, the result will also change all the time. So we take lag 2 and see the result. Then we shall take lag 4, then see the result. And then we take lag 6 and see the result. Okay, so first we take lag 2 and then we go for time settings. Okay, time variable is OBS and our data is yearly data. I select yearly, then I press OK. Okay, then I press OK. So actually this one is our VAR model, right? So here we have taken lag 2. You can see from here, this is VAR model, vector auto regressive model, and you can see this one is the dependent variable export, and this one is the actually these are all independent variable. So this one, I talk about this one. This one is the export lag 1 and this one is the export lag 2, and this one is the import lag 1, and this one is the import lag 2, and this one is the um, money supply lag 1 variable, and this one is the money supply lag 2 variable, and this is the coefficient, standard error, z statistics, and the probability value. Okay, here actually we want to check what is our null hypothesis. That we want to check, suppose import lag 1 and lag 2 jointly can cause export or not, right? And also we want to check, suppose this one, whether money supply lag 1 variable and money supply lag 2 variable can cause export or not. So that actually we want to check here, and that is Granger causality test. And also here I just come here, this is the dependent variable import, and we have lag 2, right? So we want to check, suppose export lag 1, export lag 2 can cause import or not. Or also money supply lag 1 and money supply lag 2 can cause import or not. Also here we want to check whether export lag 1, export lag 2, they jointly cause money supply or not, or import lag 1 and import lag 2, they jointly can cause money supply or not. That we want to check actually here, right? And that is Granger causality test, and that we can do now from the statistics. Make sure here we have taken only lag 2 for each variable. Okay, I go to statistics, then I go to multivariate time series, then I go to var test, and I choose the Granger causality test, right? You can see from here, Granger causality test, right? I select it. Okay, and I press OK. Okay, this is the result has come up, right? You can see the result, Granger causality wall test, right? Okay, and equation, and these are the dependent variable, suppose, right? Okay, here, so actually we set the null hypothesis. Suppose I take this one first, right? First I take this one. So here the null will be lagged import variables, lagged import variables does not cause export. That is our null hypothesis. An alternative hypothesis, lagged import variables does cause export, right? That is our alternative hypothesis. Okay, here this variable has actually two lagged variable, right? Two lagged variable. So okay, and you can see chi-square and the probability value. So probability value is 21.8%, meaning that more than 5%. So we cannot reject null hypothesis. We cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that lagged import variables does not cause export, right? And here, what about the second one, second pair? Here money, what is the probability? 35.1%, meaning that we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that lagged import variables does not cause export. Okay, so when I take all, that means I'm taking both the variables, right? All, right? I'm taking import and money supply. So here probability value is 25.1%, meaning that we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that import and money actually they do not cause export as a whole. Okay, then what about this one? This one, the probability value is 62.4%, meaning that meaning that we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that lagged export does not cause import, right? That is the null hypothesis. And alternative, lagged export variables does cause import, right? Okay, here the probability value is 62.4%, meaning that we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that lagged export variables, that means there are two lagged export variables, does not cause import. And also here money probability is more than 5%, that means money lagged money variables does not cause import. And what about all as a whole? Export and money, they as a whole does not cause import because probability value is more than 5%, so we cannot reject null hypothesis. And what about here? Here is the, I think, the same story. Export, the lagged export variables cannot cause money supply because probability value is 23.1%, but import also cannot cause money supply because the probability is more than 5%. But the problem is here, as a whole, as a whole, export and import can cause money supply because probability is 2.8%, which is less than 5%, meaning that we can reject the null hypothesis and can accept the alternative hypothesis, meaning that this one lagged, that means lagged export and import, right, as a whole can cause money supply, right? Okay, because here the probability value is less than 5%, right? Okay, so this one is the outcome when I take lag 2, but this time lag 4 will be taken. So I go to statistics as before, then go to multivariate time series as before, and go to vector auto regression model, and I just take here lag 4, right? I just take here lag 4 and I run the model. You can see lag 4, right? Lag 1, lag 2, lag 4 for every variables, right? There are lag 4. Okay, now I check the Granger causality test as before. I go to var test and then I go to Granger causality test and I press OK. Okay, you can see the whole result has been changed a lot, right? The result has been changed a lot. Okay, here you can see import can cause export. Why? Because probability value is very small, less than 5%, right? So we can, so what is our null hypothesis here? Null is lagged import does not cause export, right? So that is the first model, right? And what is alternative? Lagged import causes export. Okay, here the probability value is less than 5%, so we can reject the null hypothesis and can accept alternative hypothesis. That means lagged import causes export. Okay, here make sure we have actually here 4 lagged variables, right? Not 2. Here is 4 lagged variables can cause export. Okay, what about money? Yes, money can cause export. And what about whole? Yes, as a whole, import and money can cause export. Okay, what about the second one? This one. This one, yes, export, the lagged export variables can cause import because probability value is less than 5%, and lagged money variables also can cause import, and as a whole export and money can cause import because probability is very small, so we can reject the null hypothesis and can accept the alternative hypothesis. What about here? Export can cause money, lagged import variable also can cause money, as a whole also can cause money. Okay, so this is when I take lag 4. But when I take lag 6, so I run the model again having lag 6. So here I just make it lag 6, right? Lag 6 and run the model. So here you can see every variable has lag 6, right? Every variable has lag 6, right? Okay, then we go to statistics. Then we go to multivariate time series, var test, Granger causality test, right? We do it as before. Press OK. Okay, here is the outcome. Okay, first I take this one. What is the null hypothesis here? Lagged. That is the null hypothesis. I set lagged import does not cause export. That is null hypothesis. And alternative, lagged import does cause export, right? And make sure here are lagged import, meaning that here are 6 lagged import variables are here, right? 6 lagged import variables, right? Okay, here you can see all are significant, very highly significant. You can see import can cause export, right? And all are significant. That means import cause export, money cause export, export cause import, money cause import, export cause money, import cause money, right? That means here is bi-directional causality, right? Bi-directional causality is here, right? Bi-directional causality is here, right? Okay, so what is the decision here? The decision is when I change the number of lags, the result changes a lot. When I change the lag numbers, right, outcome changes a lot. So meaning that meaning that lag is is a important matter to change the result. The lag is a very important issue that actually changing the whole result. So so the so so now the question is how many lags we should take. How many lags we should take. So that is the question, right? We should take. How many lags we should take. So that is the important question. Is it lag 2? Is it lag 4? Or is it lag 6? Right? So that is the question now. Okay, and in future in other videos I shall be discussing how many lags you should choose. I shall be discussing how many lags you should choose, right? Right? How many lags you should choose, right? Okay, but one thing is sure, that when we change the lag, the outcome changes a lot. That is the outcome of this Granger causality test. Okay, thank you very much for being with me for a while.